So now let's continue with the analysis. The first idea that we want to add here is that every node in a KD tree corresponds to a region. So we can explain these regions again by going inductively. So for example, at the beginning, before I have anything, I could say that I have a input point that corresponds, or sorry, I have a node that corresponds to the entire point set. Okay. Then after doing this first division, so the left and the right, this subtree or this subproblem will be called P1 and this one will be P2. The left child will be assigned P1 and the right child will be assigned P2. Okay, so we have this P1 and P2 here. And here we could say that the region of the left child is essentially this left half of the plane. And the region of the right child is that half of the plane. And then that definition continues recursively. So I can show you some examples later on. So for example, when it comes to a leaf node, something like this, the region of a leaf node that denoted by some node V here is this region over here. This denotes the region of the left child of the root, and so on. So we could assign a region for every node. And one extra property that I want to highlight here is that the region of a child node is a subset of a parent node. In general, if you have, let's say if you have a node V with this region assigned to it, and let's say you want to do a vertical division, so you want to cut this region in half, and this is P1 and this is P2. The right child will be assigned this left region, and the left child will be assigned this left region, and the right child will assign that region. If the cut is vertical, so I forgot how is the order, but one of them will be assigned as a left child and the other one as a right child. In general, the region of the two children together will equal to the region of the parent. Okay, so that's a major important property of this way of assigning regions. Okay. So based on these regions, we could have a very simple data structure, procedure to answer the queries. So now let's say I have a query, right? So I want to do a search. I have a query given by this rectangle R. So I have a rectangle R that represents a query. And for now, let's say I want to report. I want to find all the points inside this rectangle R. This procedure goes like this. This query is called on a node of a KD tree. Initially, this node is set to the root of the KD tree. Okay, but as we recurse, this this procedure could be called on any node of the KD tree. If this node is a leaf node, then this is easy, right? Because we have only constant number of points stored at the leaf node. So for example, there is only 1 point stored. So we just check to see if it's inside the rectangle. If it is, we just report it. Okay. Otherwise, V is not a leaf node, which means that either we have a vertical division at V or a horizontal division at V. And then the left and the right child of V are assigned accordingly. Okay, so that we get to this else case when we don't have the internal node. But the pseudocode for both of these cases is more or less the same. Okay? We look at the left child as well as the right child. If any of them is completely inside the query, then we report all the points inside. In our cell, something like this. If the left child is completely contained inside a rectangle, and by completely contained, we mean the region, right? Remember that if the left child has a region, so let's say if the left region is like this, and the query rectangle completely contains this left region, then we know all the points inside this left region are contained inside the query. So we just report all the points inside that subtree. Otherwise, if the left subtree intersects the query, then we recurse into it, right? So this is a recursive call on the left child. And then the same thing is repeated for the right child. Okay? So for example, in this picture, when you have this query, you recurse into the left child of the root node, right? So which means that you're gonna visit this above this and then below this division line as well, and so on. Okay, so in the next recursion, until you reach this, for example, leaf node over here. Okay, so that's the query algorithm. Before going to the analysis, let me just visually represent this, or just represent this query structure inside this picture. So you have this tree. Every node is assigned a region. For every child of query node you ask if it's inside, you report all the points inside the subtree. If it's intersect, you recurse inside the subtree. Right? So you do the same question for this child. So the query procedure again is extremely simple, and the difficult part is how do we analyze this, and we're going to do that next.